So Roger is a professor at CU, he's a professor in the Environmental Studies program. He's a fellow of, now they call this series, but it looks like CIRES for me, which is the Cooperative Institute for Research in Environmental Sciences, which is one of the areas that CU Boulder is quite famous for. I was going down here and it says intro, I'll just read it verbatim. It says, I've lost it now. In 2011, began to write and research on the governance of sports organisations, including FIFA and the NCAA. So this man has clearly got broad interests. So I'm not going to waste any time, his time, introducing anymore. I'll hand over, and he's now going to entertain us. So over to you, Roger.
Thank you. Unfortunately, I'm not going to speak on FIFA today, which, if you think people argue about climate change, you should take a look at what happens in sports government. So what I'm going to do, and what I was asked to do, is talk a little bit about scale with respect to decarbonization, which refers to efforts to limit the amount of carbon dioxide that's resident in the atmosphere. And I have quite a lot of material, and I want to save about 10 or 15 minutes for discussion and questions. So I'll go through the presentation and I'll skim over some parts and hit some parts, but hopefully present a story to you that gives you an intuitive sense of the scale of this challenge. The current context with respect to climate policy, carbon dioxide, is basically that it's been put on the so-called back burner, on low heat. Around the world, governments are focused on economic growth almost exclusively. Europe has the Euro crisis. The United States has its presidential election. China and India are focused on sustaining economic growth, which has waned a bit. No one's really paying any attention to climate policy. And I think there's a very simple, straightforward explanation for why this is the case, and hopefully you'll find it convincing. Now, the mainstream approach to talking about carbon dioxide and climate change involves something like these graphs up here. What you have is, through the international negotiations, there's been a commitment that we shouldn't increase global temperatures more than 2 degrees above pre-industrial levels. What that equates to is 450 parts per million carbon dioxide. I'll explain that in a second. And what's done is that scientists create computer model projections of how the climate might evolve. They go backwards from that to different emissions trajectories. From these different trajectories, which are supposed to keep us below 2 degrees, we divide up allowable emissions and farm it out and say we need to have international negotiations that allow different countries to have only a certain amount of emissions. Now, if you're a modeler, if you're a scientist, this is a very rational, straightforward approach to the problem. For the rest of us, this is just performance art. Right? It has no intuitive meaning. Not any one of us can intuitively understand, well, what does it mean to limit the global carbon budget such that we stay below 450 parts per million? Many of you probably don't even know what I just said. I don't even know what I just said. So what I'm going to do is try to reconstruct this issue in a way that's far more intuitive. That it does not rest on putting out very pretty, colorful graphs, but which are very difficult to understand. So that's my mission. Now, to understand the nature of the problem, and the first thing for me to say is that climate change is not limited to carbon dioxide. There's many other factors that involve human impact on the climate system. Carbon dioxide is among the most important, if not the most important, and also the most difficult to deal with. So this is a bathtub. If you understand how a bathtub works, then you understand the carbon dioxide challenge. The issue is that we're putting carbon dioxide into the atmosphere. That's like water going into the bathtub. Now, the carbon dioxide doesn't stay in the atmosphere forever. Some of it gets absorbed by soils, trees. A lot of it gets absorbed by the oceans. But similarly, the water in the bathtub doesn't stay there forever. It evaporates. But if you're worried about the bathtub overflowing, that evaporation doesn't really help you on the time scales you're concerned about. So part of the problem with putting carbon dioxide in the atmosphere is it stays there for a long time, even though some of it's taken up. As we put carbon dioxide in the atmosphere, one of the things scientists argue about is, well, at what level, what amount does it become dangerous? When does our bathtub overflow? Scientists measure the concentration, the amount of carbon dioxide in the atmosphere using the term parts per million. That's molecules of carbon dioxide per million molecules in the atmosphere. Now, for a long time, 450 parts per million was presented as the threshold where danger occurs. Right now, we're about 390, 395. And one of the responses to that has been, well, 395, you tell me danger's at 450. Call me up when we're at 449. So there's been a movement lately to push for 350 as the threshold of danger rather than 450. What I'm going to suggest to you is that threshold is actually completely irrelevant to policy. The dynamics here are very simple. Some of the carbon dioxide goes into the ocean, a good share of it, but it changes the chemistry of the ocean, which has its own risks. So if we want to stop the water increasing in our bathtub, then the amount that we're putting in has to equal the amount going out. And if you don't want to use the oceans as a sponge to absorb carbon dioxide, essentially the amount going in has to go to very close to zero. Okay? So the time frame it takes us to reduce carbon dioxide emissions to very close to zero will dictate how high the water is in our bathtub. So what I'm going to present to you is some data, some information on trying to understand what does it mean to limit the increasing water in our bathtub. So here's some data, some recent data on actual emissions. So this is the water we're putting into the bathtub. The CO2 we're putting into the atmosphere. This is 1990, this is 2010. The black dots are actual emissions. These colorful lines are different scenarios that were put forward in 2000. And you can see that the world has been running very close to the upper level. Now, there was a big drop in 2009. Why does that occur, do you think? Economic crisis. And you're going to see very soon that economic activity is very closely tied to carbon dioxide emissions. But it turns out immediately thereafter, we had a record increase, and we're continuing on this trend line of rapid increases in carbon dioxide emissions. So during this era, really post-2000, when we've been most concerned about climate change and emissions, emissions have actually accelerated globally. We're doing essentially nothing to stop that water accumulating in the bathtub. Right, so here's a very simple framework, a little mnemonic, a little sentence that encompasses everything there is to know about carbon policy. And I mean that very seriously. People engage in economic activity that uses energy from carbon-emitting generation. So if you can memorize this, you can dazzle your friends at cocktail parties and impress your family. Here's why. So if we take that sentence and we turn it into variables. People, that's just population. Economic activity, that's GDP per capita. GDP is a measure of economic activity. This is just GDP per person. Using energy, that's the energy intensity of the economy. That's the total energy we consume divided by GDP. Carbon emitting generation, that's the carbon intensity of our energy supply. That's measured as carbon divided by total energy. Now we take these four factors, we put them together, units match up, which is always nice. This is something that's called the Kaya identity. That's named after the Japanese scientist Yoichi Kaya, who proposed it in the 1980s. And he proposed it as the basis for generating emission scenarios to drive global circulation models. Because if you want to know what the future climate's going to do, you need to know something about future emissions. It turns out that this Kaya identity is an incredibly powerful tool for policy analysis as well. And that's what I'm going to use it for. All right, so this Kaya identity tells us all the tools in the toolbox. If we wish to limit the amount of water in the bathtub, carbon dioxide in the atmosphere, here's your choices. You don't have any other choices. We could have less people, all else equal. We could have a smaller economy. We could increase efficiency, which means doing the same or more with less energy. It doesn't mean doing less. So conservation is not the same as improving efficiency. Or we could switch energy sources. We could generate energy with less emissions. We could switch from coal to natural gas to solar or nuclear power. I'm going to make things easier. Population and GDP per capita, if you combine them, that's just GDP. That's just economic activity. And if we combine energy intensity and carbon intensity, that's a measure of technology. It's the technologies of energy production, power plants, solar panels, and technologies of energy consumption. So computers, cars, airplanes, laser pointers, you name it. Now, right away, when I do this, we should begin to see why it's been so difficult to reduce emissions. In the book that I recently did called The Climate Fix, I introduced a concept called the Iron Law of Climate Policy. And the Iron Law of Climate Policy says people are willing to pay some price for environmental objectives, but that willingness is limited. Those limits occur at different places. It depends how wealthy people are and what they feel about the environment. Here's an opinion poll taken in the United States right after the House of Representatives passed the cap-and-trade legislation. It didn't get through the Senate, obviously. But at $80 per year, a majority of Americans said they would support a climate policy. At $770 per year, that number dropped to less than 10%. So this curve of more support when it's cheaper and less when it's more expensive would seem obvious. And it occurs at different levels. And now if I told every one of you that it would cost $1 per year to each of you to stop the water increasing in our bathtubs, how many of you would say that's a good deal? All right, a lot of people. All right, how about $1 million per year for each of you? All right, come see me about naming our center after. So obviously, there is some price threshold. And people tend to argue over, well, whether it's higher or lower in different places, but this dynamic exists everywhere. And the reason for this is straightforward. If there is one ideological commitment that governments and people have everywhere in the world, it is to economic growth. Just look at the discussion and debates that policymakers have around the world right now. Everywhere, economic growth is important. I ask my students in my classes, do you expect to get jobs after you finish university? And most of them say, yes, I'd like to get a job. Well, where do jobs come from? If you ask my colleagues, would you like to have a raise next year? It turns out most of my colleagues seem to think that getting a raise would be a good idea. So this is a broadly shared commitment. It shouldn't be surprising. I have found that people, particularly in rich university towns around the world, like to debate this point, but it seems not worth debating. I'll just show this graph to illustrate it. This is an interesting graph that shows the distribution of income around the world for 3 points in time. 1970, 2000, and an estimate for 2015. There's some normalized money here, $100 per year, $100,000 per year, and some proportion of people at each income level. And it turns out the world has been getting wealthier when measured in currency, dollar terms. This curve is moving from the left to the right. If we were talking about development policy or poverty eradication, this would be a success story, right? But if you're worried about carbon dioxide emissions, this is problematic because GDP is one of the key factors in increasing emissions. Now, there's some people who are saying, well, we can stop growth, or maybe we shouldn't have growth anymore, or even more radically, maybe we should have degrowth. Let me just say, I think that's absurd as a matter of practicality. If you ask yourself, where is this curve going to be in 2020, 2025? My expectation is that people are going to continue to try to push that off to the right. 80% of the world lives on less than $10 per day. Yes?
Where does this increased amount of wealth or money has come from?
That's a very important, where does wealth come from? I'm going to defer that until later, but it comes from innovation, doing more with less, being more efficient in our use of resources, our use of human capital, and our ability to extract more value from the resources that we have. The typical salary of an academic, academics aren't the wealthiest people in the world, but they're pretty far out on the right. It's very easy to talk about ending growth when you're way out on the far right of this curve. So what I'm going to say and I don't think it should be controversial, but I'd be happy to discuss it, is that reducing emissions by reducing GDP is just not going to happen. Any policies that we come up with are going to have to focus on the only other lever that there is, and that's technology. But right away you see we have a problem. Because if there's a commitment globally to increasing GDP, then that's going to force emissions up. We have our incentives all mixed up. If we only talk about emissions, we're missing a big part of the picture. So I'm going to use mathematics and get our incentives lined up. We want emissions to go down. We want GDP to go up. The reduction of this ratio is an indication that our technology is improving with respect to this goal of limiting the water in our bathtub. So now I'm going to show you some data, some real-world data with respect to this metric. And the good news is if you are interested, you can go to the internet and in 10 minutes download data sets and do this exact same analysis. So you don't have to believe what I'm telling you. You can go do the analysis yourself. So this term, decarbonization of the economy, is reflected in a decrease in the ratio of carbon dioxide emissions to GDP. In 2006, which was the final year for which consistent data was available when I did this analysis, it's now available in 2008, the world emitted 29 billion tons of carbon dioxide. The global economy was about $47 trillion. That gives us a number, 0.62 tons of carbon dioxide per $1,000 of GDP. Now, this number has to go down if we're going to limit the amount of water in our bathtub. But how low does it have to go? Remember, we have some targets like 450, 350 parts per million. What I'm going to suggest to you is that those targets don't matter because we're talking about a big reduction. The number I'm going to use, which comes from the international negotiations, is 80% reduction. So some good news. If you look historically, the world has been decarbonizing. This is the global economy. The metric of carbon dioxide to GDP was above 0.9, and by 2006 it was closer to 0.5. The reason for this is that the world becomes more efficient in how it uses energy, and the world has, over the long term, been switching from very carbon-intensive fuels to less carbon-intensive fuels. And you see this in the United States right now, that coal-powered electricity is being replaced very quickly by gas, which is less carbon-intensive. All right, so there's 2006. So we can ask a question. What would this curve have to look like if we wanted to reduce emissions by 80% by 2050? And if you like 60% or 99% or 50%, that's fine. Nothing I'm going to show you hinges on the precision of this number. But you know from the Kyoto Identity to answer this question, we have to say something about GDP growth. So I'm going to present a range of options here. This is for a rate of GDP growth of 1% to 5%. The historical average over 1980 to 2006 was 3.5%. I think many policymakers would be very happy if the world would average that. But the point here is fairly qualitative. We need to go from 0.62 to somewhere below 0.1. Now, this is more abstract art. What does this mean? What does this tangibly mean in terms of energy? So let's start talking about some cases. So here's the historical curve, and here's just the midpoint, what it would have to look like. So we're going to go to the United Kingdom. The reason for this, there's two reasons. One is that I spent a sabbatical in Oxford and studied British climate policy. And also, the UK has the most aggressive domestic legislation for emissions reduction. It's called the Climate Change Act. So the UK, let's look at data for the UK. So this is carbon dioxide per GDP, and just like many places around the world, you see this steady background rate of decline. The UK is actually one of the most carbon efficient big economies. They're at 0.42 tons of CO2 per $1,000 in GDP. Why is that? Well, one reason is they are offshoring their manufacturing. So these graphs show the percentage of their economy that is manufacturing, which is very carbon-intensive activity, from above 30% down to just above 10%. Similarly, loss of jobs. So some of that carbon dioxide has been moved elsewhere in the global economy. So let's ask the policy question. If we take the goals that are in law in the British Climate Change Act, which says a 34% reduction by 2022, What would this curve have to look like if the UK is going to hit its target, which is coming up soon? Here's the answer for 5 different rates of growth. When I did this, I assumed the UK would have positive rates of GDP growth, and ever since I did this analysis, the UK has been going the other direction. I'm sure David Cameron would be very happy with just even a 1%. But the point here is they need to go from 0.42 somewhere between 0.2 and 0.15 by 2022. So what does that mean? What does that actually mean in terms of energy infrastructure? I'm going to use France as a measuring stick. So here's the UK. Here's some other countries. You can see where they're at in 2006. The UK, in order to get down below 0.5, has to go through 0.3. France has the most carbon efficient big economy. Why is France so carbon efficient? Nuclear power. So on its way to 0.15, the UK has to go through 0.3. So we can ask a very practical question. What would it take for the United Kingdom to be as carbon efficient as France? Here's the French decarbonization curve. And again, downward slope, not as rapid. And of course, the French rush to nuclear power over the last several decades had nothing to do with green energy or carbon targets, and a lot to do with geopolitics, the Middle East, Germany, and so on. So there's France at 0.3. Took 20 years to go from 0.42 to 0.3. So it can be done. And the question we might ask is, can it be done in a shorter time frame? So you take France, go there, move it, then down, you squint. It tells you that by 2015 at the latest, which is coming up on us pretty quick, the UK would have to be as carbon efficient as France in order to be on target to meeting these goals. Now, the bad economy in the UK maybe has pushed this out a little bit, because here's our 1% curve, and the UK is getting closer to 0% growth, so maybe that gets us actually to 2015. So, to give you a sense of scale, to turn these abstractions into real numbers, this is the Dungeness B nuclear power plant, 1 gigawatt nuclear power plant in Kent, on the east coast of England. How many Dungeness B nuclear power plants worth of carbon-free energy would the UK need between now and 2015 to become carbon efficient as France? And let me say something very quickly, because sometimes when you say nuclear power, nobody hears anything that comes after. This is just a measuring stick. I could use wind turbines or solar panels, whatever technology you want, but we all have a sense in our mind what the magnitude of a nuclear power plant is. So here's the answer to the question. How many Dungeness Bs would it take, displacing coal and gas in the UK, up and running by 2015 to be as carbon efficient as France? The answer is 40. So I've gone out on a limb, it's in my writings, and I said it's not going to happen. It's just not going to happen. There's a climate change committee in the UK which produces a book that's like this thick, and it says that the UK could have 1 million plug-in electric vehicles, people could put insulation in their attics, they could walk to work, they could switch to wind, solar, nuclear, but the magnitude is the same. It doesn't matter if I weigh myself in pounds or kilograms. You get different numbers, but the magnitude is the same. This is an enormous effort, and it's just not conceivable that this level of effort will be achieved by 2015. And remember, that gets you about 1/3 of the way to the target. So things have been happening in UK politics that happen in politics everywhere. People are talking about changing the numbers. They're talking about, well, maybe certain things shouldn't be counted. Maybe we should change the dates. Maybe we should get rid of the law. The fact that the economy has not grown has given policymakers a little bit of breathing room, because they can say, look, our emissions are going down. But it has nothing to do with policy, it has everything to do with economics. Let's skip over this. Here's the United States. So the US has seen a remarkable reduction in its emissions. Right now the US is about 1992 levels. So this is the 23rd of January projections for US emissions. And the US is actually well below that now. They're not at the 17% reduction from 2005, but they're maybe halfway there. What's the magnitude of infrastructure needed in the US to hit the 2020, 2025, and 2030 targets? It's the equivalent of 103 nuclear power plants being installed by 2020, 226 by 2025, 355 by 2030. It's a big, big ask. The US is not going to hit its targets either. How about Australia? Australia has some phenomenal targets. Even a 5% reduction from 2005 levels is a huge reduction from projected growth. Australia has a very carbon-intensive economy. Just to get 5% below 1990, it would be 25 nuclear power plants equivalent. I've given versions of this talk and analysis in Australia, and one of the first comments I usually get is, excuse me, mate, we don't do nuclear. So what I've done for the Australians who don't do nuclear is I've expressed this in solar energy. This is the Cloncurry solar farm project. And how many of these solar farm projects would you need to get 5% below 1990 levels? About 30,000 of these solar farms. About 10 of them per day would have to come online. It's not going to happen. So let me tell you something about scale and how our policy advocacy and recommendations don't always match up with the scale of the challenge. These are some Greenpeace campaigners. This is at Heathrow in London. And if you've ever been to Heathrow, you know that the airport is running at 100% capacity, sometimes a little bit over that. And there's been a big debate over building a third runway, because London seems to think that it wants to be at the center of business activity and finance, and GDP is important. And so as part of this debate, these guys broke through the fence, they climbed in the back of a BA jet, put up this sign, I'm sure making the people inside very happy about environmentalists. Climate emergency, no third runway. So where does this fit in the scale of things? Now here's China. China, during the time that Heathrow's having this debate about one new runway, is building 100 new airports, Heathrow size or larger. So let me say again, it doesn't matter if they build that third runway at Heathrow or not. It just doesn't in a very clear mathematical sense. To put things in perspective, this is China's emissions. In 2006, 1.7 gigatons of carbon. Here's the estimated 2010 emissions with each year's increment. You see how fast China's growth is occurring. Remarkable economic growth. A lot of people moving from poverty to middle class. And what I've done here on this graph is I put the total annual emissions for several other countries. Japan, Germany, Canada, here's the UK and Australia. It turns out that the UK, the entire country, is about 3 weeks of China's emissions. So forget about the debate over Heathrow. The United Kingdom doesn't matter. Just a little blip. So what I'm telling you is not new. It's been in the literature, and what I'm trying to do is explain it in a way that makes sense. This is from Kent Caldera and colleagues in Science almost 10 years ago. To achieve stabilization at 2-degree warming. So you guys know now, 2 degrees warming, that's about 450 parts per million in our bathtub. We would need to install 900 plus or minus 500 megawatts of carbon emissions-free power generating capacity each day over the next 50 years. This is roughly the equivalent of a large carbon emissions-free power plant becoming functional in the world every day. So in my book, I've done similar math using different methods, and I come up with roughly 1 per day. 1 nuclear power plant per day coming online. Now, there's a inconvenient, uncomfortable footnote to a lot of climate policy discussions, which can be difficult to raise and talk about and when you're talking about reducing emissions, because it blows everything up. If you look at the models that are used to project future emissions, and you look at the so-called success stories, the way that we're going to reduce emissions, whether it's with the UK Climate Act or broadly, globally, virtually all of those studies leave the 1.5 billion people who lack access to electricity around the world. Maybe it's 2 billion, maybe it's 2.5 billion. They leave them in the dark. Why is that? Because if you are trying to decarbonize, as I've talked about, and increase the number of people on the grid by 2 billion, your math just doesn't work out. You blow up the math. If you present climate policy as a trade-off between rich world environmentalists who want to reduce emissions and people who are from less developed countries who are trying to get their citizens access to electricity, guess what? The environmental agenda will lose out. And this is exactly what's happened in the international negotiations over and over and over again. China and India in particularly have said, we have a right to develop. We need to use energy. We don't have the technologies at scale of renewables yet, and so we will develop with the energies that we have. So what I have argued is that we need to change the way that we talk and think about this issue. So if you listen to a lot of the US, North American, European discussions of climate, you'll hear these sorts of things said often. We use too much energy. Fossil fuels are too cheap. We need to make them more expensive through carbon trading or a carbon tax to create incentives so people won't use them. But the reality is the world needs a lot more energy, vastly more energy, if the aspirations of half the planet are going to be actually realized. You can come up with the most fantastic stories in your mind of efficiency gains in the US and Europe, and global energy is still going to need to increase dramatically. One of the reasons that people don't have access to energy around the world is that fossil fuels are too expensive. In India, just this week, there was a major blackout, and there's a satirical newspaper here in the United States called The Onion. And The Onion said in its headline, "India fixes blackout. 300 million people still without electricity." One of the reasons that there's so many people around the world who don't have access to electricity is because energy costs too much. One of the goals we should have is to make it cheaper. So, how fast can decarbonization occur? And one of the things you should take from my talk is there's a lot of aspects of climate policy where the proper answer is, we don't know. There's a lot of very certain claims that are made about energy and climate, and the reality is we are in uncharted territory in a lot of respects. So the honest answer is nobody knows. If you look historically at how fast decarbonization has occurred, this background rate that I've showed you has occurred about 1 to 2% per year. Some countries have achieved rates of greater than 2% per year. I had my students a few years ago do an exercise. I said, find me the fastest rate of decarbonization for a 5-year period or longer, and tell me what it was. And the winner was Japan. In the early 1980s, Japan got rid of its aluminum industry, which was very energy intensive, but also not very successful, and they boosted their rate of decarbonization to 4.4% per year. Pretty impressive. However, the United States were to achieve 17% reduction, which Barack Obama has committed to, by 2020, while maintaining modest economic growth, say 2%, requires rates of decarbonization greater than 5% per year. It's never been done. It doesn't mean it can't be done, but it means that we don't know how to do it. Now, the policy options that we often talk about are not up to the task. And this idea of setting targets and timetables is exactly backwards because we don't know how to achieve the goal. So think about that Kyoto identity again. Emissions equals GDP times technology. If we don't have the technology ready at scale, there's only one other lever left to reduce emissions, which is GDP. No policymaker is going to allow GDP to suffer to meet climate objectives. So what is done? What is done is we build things like international offsets, safety valves, all sorts of tricks in the legislation that allow the appearance of emissions to be reduced, but really nothing to happen until the technology is actually there. Some analyses of the US cap and trade bill suggested that business as usual would continue at least to 2025 or longer. If you look at the European trading scheme, the ETS, which is the most, we have the most experience with in terms of carbon pricing, the rate of decarbonization of the EU 15 before and after the ETS is the same. What the ETS has done is it's taken the background rate of decarbonization, made it obvious, and called it climate policy. Right now, Europe is going in the other direction. Germany is building a lot of new coal, and the last thing that German industry wants right now is any other restrictions that limit growth and the problems with the euro. Now, a carbon tax alone can't do the job for the exact same reasons. In my book, I recommend a carbon tax, but one that is low enough that it doesn't violate the iron law, because people are willing to pay some price, but you don't use a carbon tax or carbon price to change people's behavior. Because if people feel the impact of carbon pricing, they will change their behavior. They will vote somebody out of office, and they'll say, give me somebody who gives me cheap energy. But one thing to recognize is the magnitude of the global energy economy. So the global economy is something like $60 trillion, and about 10 trillion of that is energy. And if you put a very small carbon price or energy tax on that, you can raise an enormous amount of money. So what I've argued is that we should think about how we deal with other so-called wicked problems when we think about climate change. If the world needs vastly more energy, and we need cheaper energy, then there are compelling reasons to invest in energy innovation. Not to put limits or to make energy more expensive around the world, but to do two things. One is if the rich world really wants to reduce carbon emissions and the developing parts of the world want more energy access, then there's a shared ambition there in innovation for lower priced energy. Think about how we advance human lifespans. I'll just talk about this one, but we could talk about the others in the discussion. Imagine that it's 1930. We have a global summit saying that globally lifespans are less than 60 years. And we're going to set a target. By 2010, we want lifespans to be 75 years worldwide, on average. What we're going to do is we're going to give each country death permits. And you can trade them. And so if you have too many deaths, you have to pay for it. And that'll create an incentive to invest in medical R&D in public health. Now people laugh, you're laughing, that's funny. That's exactly what we've done. Exactly what we've done with energy. The only way we're going to make progress with decarbonizing our economy is the same way we make progress with human lifespans. We invest in innovation in public health is like efficiency, and we make progress disease by disease, public health issue by public health issue. And as we make progress, we get closer and closer to achieving these longer term goals. No one knows how long human lifespans are going to be 20, 30, 40 years from now, but that doesn't seem to prevent us from investing in a way that moves us towards that goal. Energy is going to be very much the same way. And I would say this is not an academic debate. This is how actually policies are developing worldwide, and we can either accept that and reinforce it, or try to deny what's fairly obvious. I'm going to close with two pictures. This is The World from Space from Jesse Ausubel and one of his collaborators. Essentially, today. So you see Northern Europe, you see North America. They asked, what would the world look like if everyone globally lived at the same economic level as North Americans and Europeans? That's this world. And I show this to my students, and we have a long discussion. Somebody says, first of all, what a nightmare. Can you imagine all the carbon dioxide emissions coming? And then right away, somebody else will say, yeah, but think about all the human potential that's freed up and realized in parts of the world that today are pretty dark when there is access to electricity. It's an interesting debate to have in the classroom, and it brings forth a lot of issue. But the reality is this is the world we're moving towards. And what I like to argue is that we can do it intelligently, wisely, or we can do it not so intelligently. That's the choice. And a lot of the debate about climate change, which is a debate focused on people's favorite technologies or their views of science, is completely oblivious to this much larger context going on around the world. All right, here's how you can find me. Pielke at colorado.edu. There's a lot of papers. There's a book. I have a blog where I talk about these things, and I'd be happy to chat with you for the next 10 or 15 minutes.
Thank you very much indeed. I'm not sure I appreciate the sentence that UK doesn't matter. You actually did say that at one stage. I think Peter and I may disagree. So, do we have a question? You surprised me.
Quick question,
Yeah.
Sorry.
Winning the Cold War as an example of this sort of incremental progress. The Cold War wasn't won through targets and timetables. The Cold War was won through basically an innovation race, right? The West said, well, we're going to go to the moon first. And of course, going to the moon was an example to show we could drop missiles anywhere we want around the world, with plenty of investments in a technology arms race. Now, the point here isn't whether you think the Cold War was worth winning, yes or no, but the way that was addressed. It was a very complicated, globally complex issue, was incremental year by year, with really, if you add up the numbers, it's something like $500 to $1 billion per year in direct military investments over a generation. That should tell us something about the scale of investment that would be needed to decarbonize the economy.
Changing the topics now. It's just about plausible that for $1 billion you could stick enough sulfate up in the upper atmosphere to change the temperature. Now, that's a sort of an interesting thing because it turns out that there are lots of people who have and in fact that could be unilateral global policy which could be taken on so far in order to care about this. Is that actually a plausible one? Because I've heard it from a number of sources, including the President of the National Academy.
Yeah, so the question is...
And where does that drive thinking?
Yeah, so in my book I actually talk a lot about geoengineering, and just to put my cards, I think it's a horrible idea, and I don't think it'll ever happen. That's the good news. There are experts who think that for billions of dollars, let's say, they can put enough stuff into the upper atmosphere to reflect sunlight and then change radiative forcing such that the temperatures. Number one, I don't think that deals with the real nature of the problem that we're talking about. And number two, it doesn't change any of the dynamics I'm talking about here because it ignores what I think is a more fundamental reality, is that the problem of climate change is not just that we're altering climate. It's that we're altering the climate in a context where we use and consume massive amounts of energy. If everything in the world was exactly the same, except we changed it by 1 degree, I would say that the vast majority of issues that lead to human suffering around the world, inability to reach human potential, would not be touched. And I think this is part of the problem, is that a lot of the discussion about climate change, we've taken the average temperature of the Earth or the amount of carbon dioxide as a measure of well-being, human well-being. And I think that if we talk about climate change, not as how do we modulate the temperature of the Earth, but how do we provide enough clean energy for eventually 10 or 11 billion people. I often argue that you don't even know anything about carbon dioxide to solve this problem. There's one number you should pay attention to. It's the proportion of carbon-free energy that we consume. Right now it's about 10% in a round number. If we're going to stabilize carbon dioxide in the atmosphere, it has to be more than 90%. And that number is pretty much insensitive to the amount of total energy we consume. We need cheaper and more abundant energy. If we can get to that metric, then we don't have to worry about the arguments over geoengineering and so on. I think that's a little bit Dr. Strangelove, but I'll leave it there.
I have a question.
Yes.
So you made a statement about Japan improving things by stopping making aluminium.
Yep.
So are there other examples throughout the world where a country could make a huge impact by simply stopping doing one thing? And I have to confess, I do have an example in my mind, which is in the UK, where someone once told me that 10% of the electricity produced in the UK went to making sodium hydroxide by electrolysing brine. So if they just turned that off, that's a 10% saving. We wouldn't have any sodium hydroxide or chlorine, but it would be a big hit. So are there other examples?
Yeah, and it's important to recognize that these examples, it's a little bit like you have a balloon full of air, and you squeeze it, and the air goes somewhere else. And the world didn't stop consuming aluminum when Japan got rid of it. It went to Indonesia. And so we were still suffering those emissions. So I think the short answer to your question is no. we're not going to make a big dent in this issue by stopping doing certain things. The two real success stories that are out there with respect to decarbonization are Sweden and France. Sweden because of nuclear power and its hydroelectric power, which not every country has, but France in particular because of nuclear power. And right now, the only technology that exists at scale that could dramatically accelerate decarbonization is nuclear power. It's very controversial socially. It takes a long time to build. If there's a great test case going on right now in Germany, where there's a commitment to getting off of fossil fuels and nuclear power as fast as possible. And Germany is showing us you can't do it because Germany's building a lot of coal plants. The technologies just aren't there. And if you look at Japan, if you look at the United States, if you look at most of Europe, if you give people a trade-off of climate risks from carbon dioxide and fears of radiation, it seems that most of the public would rather take the climate risk than the nuclear risk. And in democratic systems, that's a perfectly legitimate outcome. But we should realize that's the choice that's being made. The numbers I showed you here should tell you that even with rapid growth in solar and wind, it's just the numbers are overwhelming. Millions of installations that we need worldwide. And it turns out, guess what? Wind and solar are controversial also. Take the UK, and Australia, and the eastern United States, where there's a lot of public opposition to new wind turbines because it ruins the landscape. Every technology has its proponents and opponents. And the one thing I'm pretty sure is that if we take all of our technologies off the table because someone objects to it, we're just going to stick with what we have, which is mostly coal and an increasing amount of gas. But that's not going to change any underlying dynamics.
So I was just going to ask a question. It seems as though the African region isn't producing as much or doing as much damage as the rest of the world. But I'm assuming that's because they probably have less energy consumption than everybody else. But as you know, there's just so much effort right now to get Africa lit up, as it were. Now, are you aware of any kind of general guidelines and structures to ensure that when Africa is developing in terms of generating electricity, there's some kind of development management to ensure that when they do get to the point that they are where the Western world is, they aren't sort of building up this kind of problem that we're having now?
Yeah, I think it's a great question. And I mean, you're exactly right. That's why Africa doesn't have a big role in this talk. I would guess 10 years from now, if I'm giving this talk, instead of talking about India, we're talking about Africa. 800 million people who have every much of an interest and right to energy as people in the East today. I mean, the short answer to your question is that Africa is looking to develop like everyone else is, which is on fossil fuels. And there's a big reason why China is investing enormous resources in Africa, in Mozambique, in Nigeria, elsewhere, because not only do they want to secure their own energy security, but there's a lot of untapped potential there. The challenge is that since the low carbon energy is not economically viable at scale today, we're going to develop one or the other without it. So this is where an investment in, when I say investment, I mean hundreds of billions of dollars a year in energy innovation. And if you like it for climate reasons, great. But if you like it because you want to light up Africa, that's great too. Because Africa is going to be lit up. And it's going to happen. And we're kidding ourselves if we think, well, let's tell people in India and Africa that they can have solar-powered cook stoves. I mean, one of the things that was most eye-opening to me as I've done my research was to learn the UN's definition of energy access. Energy access means access to a 40-watt light bulb equivalent 4 hours a day. Right? So a lot of you sitting there with your cell phones and computers. It doesn't work. It just doesn't add up. Energy access is not a threshold. Energy access is a progression. And it turns out people seem to like air conditioning, refrigerators, cars, airplane trips. And it's very hard to see that progression is going to stop anywhere in the world at any time.
You rightly pointed out that in all these debates we often overlook the 1.5 million billion,
Yeah.
or more people who don't have electricity. But aren't there also people who will probably be most affected by climate change? When I look at Bangladesh, which will just disappear when the ocean will rise. When I look at changing climate patterns which affect agriculture and stuff like that, aren't those especially the people who are most vulnerable to those two? So,
Could be, yeah. But so the point is, we don't have to worry about them?
no,
They'll wash away?
It is the point that maybe that's a way of explaining to them why they shouldn't make the same mistakes in their developments that we made in our development.
Yeah, I have an extended passage in my book, and maybe I'll just close with this, where there's a noted environmentalist in the United States named Bill McKibben. And a few years ago, there was a big debate in India about the World Bank underwriting the building of a big coal plant. And Bill McKibben wrote something to the effect that there's probably some young Indian child who's sitting there who probably doesn't want that coal plant to be built because he's worried about rising seas and the impacts going forward. Then a very prominent U.S. journalist, Andy Revkin, wrote back and said, well, that young Indian boy is probably sitting there in the dark without access to electricity and a lot of the modern convenience of life, and he'd probably be very willing to trade off those impacts. If you look around the world at where the most vulnerability is to climate impacts, it's not here in the United States, it's not in Europe, it's not in developed China or developed India, it's where people are poor. And it turns out that one of the most effective strategies of reducing people's vulnerability to climate is for them to become rich. So it seems to me that telling people, don't make our mistakes, if that's received as a message as don't develop, stay poor, then we find ourselves exactly where the international climate negotiations are today, where the reality is, and the Indian delegation and the Chinese delegation have said this quite openly, we think that the climate agenda is a strategy to keep us down. And unless it can be framed in a virtuous cycle that promotes development, promotes wealth generation, any argument that is predicated on limiting that is, I think, going to find very little common ground around the world.
No, I think there is some problem. United States and European countries are not talking about carbon emission in terms of population. If you scale your carbon emission in terms of population, so I think European countries and US are highest at levels.
So you're talking about per capita
Yeah.
emission. Yeah, and this is the sort of thing that we get reduced to in this debate. There's a big debate in whether Europe or the United States is more virtuous. And there's a debate that says, well, how much is being emitted per person? With respect to the bathtub, none of that actually matters. It doesn't matter. I would start from a position that everyone around the world has a right to access as much energy as they can consume with respect to their, the Millennium Development Goals, say. And that we have to figure out a way to provide that. And pointing fingers and say, well, America, you are at 21 tons per person, and India, you're at 2.4 tons per person. What that tells us is that India is relatively poor compared to the United States. It's probably not going to be well received in the United States for the United States to say, well, you need to reduce your economic activity, and it's not going to be well received in India to say, well, you need to stay poor. So I think that if the debate's going to become constructive, it has to focus on, again, go back to that Kaya identity, which is a great mind-focusing ability, and say, where's the levers for action? The levers for action are not arguing about science, they're not arguing about historical responsibility or ethics. Whether you like it or not, all of the action is with respect to technology. And the policies we ought to be focusing on are what are those policies that we can use to accelerate technological innovation much faster than we have in the past. And nothing else is going to address this problem. There's a lot of other issues that tend to piggyback on climate change. Whether it's forests or equity or women's rights, they're all important issues. But if it is climate change and carbon that you care about, it's pretty straightforward. I'm happy to keep taking questions if it's okay.
Very good. One last question.
I was just going to say that I know that the 40-watt bulb doesn't solve the problem of the world.
Right.
And neither does the Cookstone project, for instance. But you will find that the organizations, normally not-for-profits, like myself, that get involved with these little projects, they kind of provide a mechanism to generate wealth for these very impoverished people, as it were. Because it's very difficult to say to a poor person, we're waiting for the big $200 billion project that's going to come and light up Africa. And while we're waiting, we expect you to be poor. Do you see what I mean? So those cookstove projects, the little light bulb projects, the little projects that provide minimal light, as it were, sometimes 4 hours, sometimes 8 hours, they also provide a source of generation for income and in terms of distribution. So they're very, very key to these very, not well-to-do communities, most times villages.
Yeah, I accept that 100%, and I agree with you. But it seems to me, again, speaking from the perspective of the United States, one of the policy recommendations we often see is not how do we help Africa continue to develop, or India, or where else. It's how do we put into our models higher quality poor people so that they have cook stoves in the future. And in none of these models do they have refrigerators. And
Can I ask that question?
yep.
In the back of the, I work for the West African Forum,
Yep.
African Forum for Environmental Education, and the way we look at it, we need quick wins, which are firefighting strategies, which solve the problems of today, but then we need bigger scales, so that we're also promoting large estates that are, self-powering. We're promoting industries that are self-powering. But yes, people tend, organizations, not-for-profits tend to look at just as firefighting. And yes, we do need bigger policies to take care of, long-term strategy, really is what we're talking about. But I think the million-dollar question is who's doing this?
Yeah, I think you hit the key there, is that we have to keep attention to scale. And one of the frustrating realities of the carbon and climate debate, and I mean this quite seriously, if you look at the scale of the Heathrow runway tragedy, that doesn't matter. The frustrating thing is that as individual citizens or in our communities, there's essentially nothing we can do to improve the state of this problem. This problem is going to be addressed through large-scale investments in innovation at the national and international level. We need the equivalent of a technological revolution in energy like we've seen in agriculture. So the Green Revolution was another example that said. That occurred not because of people doing their individual action, but because of large-scale investment. It's very frustrating to realize that, but at the same time, it's also empowering because we have a way forward. You ask who's doing this? That's a great question, because a lot of the debate over climate change is finger-pointing and nastiness, and it becomes politicized. If you look at Australia, they've had an extended decade-long debate over climate change. It's really not about climate change. It's about the left and the right in Australian politics. And so until innovation gets to the center, I'm pretty sure you'll see those dots continuing to increase, no matter what we say or argue about each other.
Okay, I think we should stop there and thank Roger once again.